This video will help you with linear equations word problems from tables. So we have our situation. Julia got a delivery order. She took some time to get ready, and then she rode her bicycle at a constant speed. The table compares the distance Julia made in kilometers and the time since she got the order in minutes, and then we've got our table. Ultimately, it's asking how long did it take Julia to ride 1 kilometer. So I put this table here into Desmos. That's always a great starting point. And then I zoomed in a little bit so that I could see my points. Now, what I want to do is find what my slope is because it's saying how many minutes does it take per kilometer. So if I look here, you can either do this mathematically. So you can say 64 minus 52 divided by 9 minus 7, which we get 6. Or you can count the boxes. So we go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we went over 1, 2. So 12 divided by 2 is 6. Is 6. So what this is saying is that it takes her 6 minutes per kilometer, 6 minutes per 1 kilometer. So my answer for this is going to be 6 minutes. Next, we have a certain engine rotation speed increases, its temperature increases at a constant rate. The table compares the engine's rotation speed in cycles per second and its temperature in degrees Celsius. What is the engine's temperature at rest? So what I'm going to do, I'm going to pause this and I'm going to add this table to Desmos. So you should do that too. Okay, so I've got my purple dots here, which represent the points given to me in the table. Now it wants to know what's the engine's temperature at rest. So that means it's not rotating at all. We're looking for 0 rotation speed. So if I look at my x values, they're all going down by 3. And then if I look at my y values, I've got 27 minus 24.6. It's going down by 2.4. 24.6 minus 22.2. It's going down by 2.4. So what I can do here, what I did here was put in 6, 3, and 0 because I'm subtracting 3 every time so that I can find what the temperature at rest is going to be. So I'm going to take 22.2, and then I'm going to subtract 2.4. I get this is 19.8. So I'm going to take 19.8, subtract 2.4, which is 17.4. And then lastly, 17.4 minus 2.4, which gives me 15. And if I look at my dots, this still makes a perfect line, which is what I'm looking for. So my answer for this is going to be 15 degrees Celsius because when x is 0, so 0 for the rotation speed, y is 15, which is my temperature degrees Celsius. Last problem that we're going to do together, it says the ground floor of a tower has a very high ceiling and the residential floors above it have a constant smaller height. The table compares the floor number and the height of the ceiling above the ground in meters. The ground floor is floor 0 and floors 1 and up are the residential floors. We have a table. I put it in Desmos. You should do that too. And then it's saying what's the height of each residential floor. So the height per floor. What this is asking me to find is the slope. So you can either count the dots, or what we can do is solve this algebraically. So I'm going to take this y, and then I'm going to subtract the y right above it, 54. And then I'm going to take my second x. So I'm starting with 22, and then I'm going to subtract 15. And I get that each floor is 3.2 meters because that's my slope. Meters per floor. So you would type 3.2 here and then move on to your next problem.